Hi everybody, hope you're doing well. Today we're going to look at 10.4, how to divide with radicals. I've already got our first example up on the board and I'm on take 3 so far. So I'm going to go ahead and get started without too much preface to our problems here today. Okay, so our first example, I put perfect squares everywhere. There are no common factors. So if this was an example you were doing for homework, just take the square root of the numerator, which would be 9x, take the square root of the denominator, which would be 5y. There are no common factors, done. There's nothing else you can reduce. This problem is done. Moving on. Our second example. Square root of 700 x over the square root of 7x. All right. So now we do have common factors. And even though we have two separate radicals, I would suggest to you to rewrite it. And you can either rewrite the whole thing, or when you go to do your homework, just write it underneath one huge radical. And then reduce before you simplify. I think I put this in the notes as well. You want to reduce it first, and then you're going to simplify using the concepts we learned in 10.3. So what does that mean? Well, first of all, if you have x in the numerator, x in the denominator, those are going to cancel. Secondly, 7 divides straight into 700, leaving 100. So after reducing in step 1, we look at a square root of 100, which you can break it down, but this is what I mentioned at the end of that video yesterday for 10.3. You know the square root of 100 is 10, and you're done with the problem. All right, example 3. Of course, it's going to always get a little bit more challenging, and I might not be doing quite as many examples here with you on the chalkboard as I would be on the classroom or in the classroom. All right, so our number one rule here, what you need to think is hear my voice in your head, reduce first, reduce first. So write that all underneath 1. Maybe I won't stay with the pink chalk through the whole problem. But you want to rewrite that all underneath one single radical. And now reduce. So 2 goes into 64 32 times. Remember, it's still going to be under the 5th root, so 32 times. We have 8 to the 1st power, 8 to the 11th power. 11 take away 1 is 8 to the 10th. And now we're going to use the concepts we learned yesterday. Now, as it turns out, 32 is 2 to the 5th power, but you might not know that just by looking at it, and so we're going to break that down. And you will see for yourself that we have 1, 2, 3, 4, 5 2s. So if I circle that entire group of 2, 4 of them cancel, and 1, 2 is going to break out of that square root. So I'm going to write the answer right there. What do we do with that variable? Well, if you needed a little reinforcement from yesterday, you're going to divide the exponent by the index. Oh, I don't know that you can see this. Hopefully I'm not off screen. 10 divided by 5 is 2. So our final answer is 2a squared. Let's make it harder. All right, so this time I have the square root of 75ab over 3 radical 3. Okay. This 3 right here is not underneath the square root. So when you rewrite it, that can't go with. You have to keep that guy separate. I wish I didn't write so big. Okay. So I would rewrite this. You know we're going to write that as one big radical. So 3 divides into 75 25 times. So this is going to be the square root of 25 AB over 3. And then ask yourself if there's anything further you can do. Well, the square root of 25 is 5. So we have 5AB over 3. And we're done. All right, so far so good, hopefully. It does get just a little bit trickier. This next piece is known as rationalizing the denominator. I'm not going to write that all out. You know it's not going to fit if I try to write that all out. I put it in the notes. It's in your book. When do you rationalize the denominator? Well, somewhere along the way, people not me, decided that you cannot have a square root in the denominator of a fraction. And actually what ends up happening is that if you take enough higher level calculus, the rule reverses. But for our level, right now, the rule stands is that you cannot leave your answer with a radical in the denominator. So we use this method called rationalizing. What that means for something like this is you simply take this question and multiply the top and the bottom by whatever that is. You know that if we multiply the same number by both the numerator and the denominator, this value right here is 1. So it doesn't change the value of our fraction. And then kind of watch how the radical disappears. 11 times 3 is radical 33. 3 times 3 is the square root of 9, but we know the square root of 9 is 3. So the radical switches from the denominator to the numerator. This answer looks more complicated, to me anyways, than what the original problem did, but it's just the method that we have to go through. So I know that it might seem like a frustrating skill to learn, because this might look easier to most of us. All right, you cannot divide the 3 into the 33 because the 3 is not underneath the radical, but the 33 is. So that's your final answer. Done. If you can simplify under the radical, you've got to simplify it. Let's do another one. Square root of 5 over 2 radical 7. All right, so in this example, the 2 is not underneath the radical. So the 2's fine. It can stay. You can have a fraction with the number in the bottom, otherwise it wouldn't be a fraction. So what we need to multiply here by is radical 7 over radical 7. Just let the 2 kind of go to the final answer. 5 times 7 is the square root of 35. 7 times 7, watch this part. 7 times 7 is radical 49, which is 7. And there's still a 2 right there. 2 times 7 is 14. Now, again, you might think, well, both of these are divisible by 7. Well, that was clear because we multiplied them both by 7. But this guy's not in the radical, that guy is. This is our final answer. All right, we're down to, I think, our last problem. The good news about rationalizing is that there are some trickier examples out there. We don't have time to go through all of that. So that is one of the pieces. So if you're reading the book and you're like, gosh, she didn't cover this, I took that all out of the homework. I'm not going to test you on the more complex rationalizing. We will only ever do square roots, just in the interest of time. So you have a lot of math to learn in 4 weeks, but it is just kind of those basic skills out of each lesson. All right, let's try this one. Okay, you could multiply top and bottom by square root of 20. That would be fine. You're going to end up with a lot more simplification to do if you do that. So what I would do again is simplify first, reduce first, and simplify first if you can. So 20 is 2 times 10. 10 is 2 times 5. We have a pair of 2's. One guy cancels. That 2 comes out. That 5 stays underneath the radical. So this becomes the square root of 3x over 2 radical 5. And now, instead of multiplying by a number as big as radical 20, we only need to multiply the top and bottom by the square root of 5. So multiply here, we get radical 15x. Multiply here, we get, where should I put that? 5 times 5 is 25, so we're going to have 2 times the square root of 25, which is 2 times 5, which is 10. So that's it. Hopefully I did enough examples for this lesson. I don't think you have that many homework problems. I don't recall off the top of my head. Again, let me know how I can help you, and you guys take care, and I hope you're not going too stir crazy. Now you have all that math homework to look at. So thanks. Bye.